Okay, so um, this will be part two of the functional groups video. So remember, just as revision, we should recall that functional groups are essentially something of a character that exists within an organic molecule that gives that organic molecule its chemical properties and some physical properties, not too much though. But let's go over the level three shapes, not shapes, functional groups. So the first group that we are going to look at is aldehydes. And aldehydes is represented by the following um, functional group. It involves a C double bonded to an O at the end of a carbon chain. Okay, and so what that essentially looks like is something like this. Double bond O and H, and we can fill in these H's over here. And so that's essentially a really easy thing to recognize. It's this idea that this portion here, this double bond O, is at the end of a carbon chain. Okay, not to be confused with carboxylic acid, because remember carboxylic acid has an OH, whereas aldehydes, they just have a single H because the double bond, it's just really about the double bond O. Um, Carbon can have four bonds. Let's just do that as R. And so that's why there's an H on the right hand side. Okay. Let's look at ketones now. Ketones are very similar to the idea that we need the double bond O, but the only difference is that the double bond O is situated in the middle of the carbon chain. Okay. So recall that this R, the idea of R, that stands for rest of the chain in the organic molecule. And so comparing that to aldehydes, we can see that in the example where we have prop, 3 carbons, an aldehyde would be where the double bond is at the end, and the ketone, so I'll just label this aldehyde. In the case of this ketone, we would just see that the double bond is in the middle. Okay. Now I won't go over any reactions, but this has some key influences in reaction chemistry. Okay, chemistry. Okay, so we'll come back a bit to that later. This is redox, by the way, redox chemistry. Now, esters, amides, and acyl halides. When we're looking at esters, amides, and acid chlorides or acyl halides, acid chlorides, they are all known as carboxylic acid derivatives. Okay, and the reason why is because if we look at a carboxylic acid, essentially what is happening with these carboxylic acid derivatives is that this is going to be replaced with something else. Okay. Okay. So when we are looking at esters, okay, amides. Okay, let's draw. I'll do it like this. Okay, let's draw the carboxylic acid first, and then I'll show you what the actual functional group looks like. Okay, so when we're looking at esters, the idea behind the ester is that we are replacing that OH group that we had before I rubbed it out. We are replacing it with a carbon chain. And so this idea where we have a double bond O to the C, but then we also have another singly bonded O followed by another carbon chain, because remember R means the rest of the chain of carbons. Okay, this is what we call as an ester. And so an ester would look like something like this. Okay, where we have this main component over here, and then we have this added chain over here where the OH used to be. All right, now in a similar case over here, if we rub this OH out and we replace it with an amine group, okay, let's go red. What we get now is called an amide. Okay, and then over here, similarly, if we replace this over here with a chloride group, okay, and that's how we get this acid chloride group. Okay, keep in mind that at university they call it acyl halide, okay, because usually it's actually represented like this, where this X, hopefully you guys remember from the first video, is a halogen. So it doesn't necessarily need to be a chloride. Okay, it can also be an iodine or fluoride or bromine. But for NCEA, they specifically want you to look at chlorine. Okay, so that's basically it in terms of the added functional groups for level 3. It's all revolved around this idea of C double bond O. Okay, so if we go over here, just to recap, okay, level 3 functional groups, okay, they all revolve around C double bond O structures. Okay, and then aldehydes is like at the end, ketones are in the middle. Okay, and then we have our carboxylic acids derivatives, where we have this replaced with either a Cl, which will give us a acyl chloride or acid chloride. If it's replaced with a NH2 group, then it's an amide. And if it's replaced with like an O and then the rest of the chain, then we get a ester. Okay, so that's a real quick demonstration of each of the functional groups in level 2, and I hope that it helped. I think the next video we will work on recognizing functional groups within specific examples.